All right, so we're going to think about domain and range in this video, and I'm going to start with a problem that I really think is helpful. Another teacher wrote this on the board, and I'm just curious if it has meaning to you. So go ahead and pause the video and think about that for a second. Well, hopefully this has some sort of meaning because you know what this is. Oops, excuse me. You know what this is right here. It's an inequality, and it's saying, hey, there are some values being x, and the values x is bigger than or equal to 2, but that value is also less than 5. And so we could think of things that belong in here, like 3. 3 belongs in there because it's bigger than or equal to 2, and it's also less than 5. The number 2 belongs in there because it's greater than or equal to 2, and it's also less than 5. Numbers like pi belong in there because pi is really just like 3.14159, and it keeps going forever, but it is bigger than 2 and less than 5. So hopefully this notation makes a little bit of intuitive sense for you. So in the past, we've thought about inputs and outputs for domain and range. But just know that the domain is really a collection of all the possible x values. And the range is the set of outputs, or all of the possible y values, knowing what we know about the domain. So we've got two examples here. In this first example is discrete. And so we really have domain is a list of the possible inputs. So it looks like there's something at -5. There's something at -5, there's something at -4, -3, -2, -1, 0, 1, 2, and 3. 3 being right there. So this is the domain. It's a collection of dots and evidence there. Well, if I had this labeled, I'll tell you what these are. This is 1, and this is going to be 4, and this is 5, or excuse me, this is going to be 9 and 16. I should have had those in there before the video. And we can think about a range, and knowing that the only inputs are -5, -4, -3, -2, our outputs are the y values, all the possible y values, where the lowest possible y value here is at 0, so our range is 0 and 1 and 4 and 9 and 16. Well, that's it. There are no more. Even though it repeats, there's one there and one there. They're both at 16. Well, here we've got a continuous function. This red line is a continuous function. And in fact, I should have done a better job. They go on forever. And so we can think of the domain as all the possible values, all the sets of x, where x is between -infinity, because it goes to the left direction forever, to +infinity, because it goes to the right direction forever. So x is bigger than infinity, but it's also less than +infinity. It's bigger than -infinity, but less than positive. The range is the set of y values. So I'm thinking about the lowest it can possibly go is 0. So the lower side, it could be 0. So it's the set of all x, where x, it's got to be bigger than or equal to 0. And x keeps going up forever. So x is going to be less than infinity. And the trick here is that it can never be infinity, but it has to be less than infinity because nothing can be bigger than infinity. And I think there's some notation, there's some slight nuance to that. All right, go ahead and pause the video and try, we already did this actually, which is kind of interesting. We did something called interval notation, and there's also something called set notation, and we'll talk a little bit more about those in just a moment. So just know that infinity exists, but we actually can't get there. That's what I was trying to say in the moment. There's something called set builder notation, and it's the thing that we just did. It says we're thinking about the set of all x values for the domain, where, and it's just a vertical line, the information about the possible values of x's. So here, it's the set of all x's where x is less than or equal to 3, or excuse me, 3 is less than or equal to x, and x is less than or equal to 4. So x is somewhere in between 4, but it could include 4, and could also include 3. So like 3.5 would be a value in that set. And then there's also interval notation. And the same thing, if it can equal, we're intervaling, so it's almost like an ordered pair, but there's two parts to it. There's the lower bound, and then there's the upper bound. And so here, we're thinking about, hey, it goes from 3 to 4, so it goes from 3 to 4. And the trick here is where students tend to get confused is this a hard bracket like a square, or is it a soft bracket like a parenthesis? And I'll talk a little bit about more. Take a look at this. Go ahead and pause the video and see if you can identify when is it a soft curvy parenthesis, and when is it a hard bracket based on the set builder notation. You're going to need to know both notations for this class. So go ahead and pause the video and try it out. All right, so hopefully you've taken a moment to think about that, and you've noticed that if it's a hard bracket, it's a hard bracket, so you use the left bracket and the right bracket when something is equal to that end value, and you use the soft bracket or a parenthesis when they don't mean equal. And just so you know, you can never be equal to infinity. So if there's an infinity in there, we always put a parenthesis. We always put a parenthesis next to infinity. So take a moment, just this sentence doesn't make much sense, and just consider why does this sentence not make sense? Hopefully you've taken a moment to think about why it doesn't make sense. X is greater than 10, but also less than -5. Somehow that doesn't make sense, that I'd be bigger than one value and less than a smaller value. So there is nothing in this set. This is kind of nonsense, if you will. But it's something to consider. So be careful when you're writing the less than and equal to and what goes where, because this student probably meant to flip them the other direction. So how do I write domain and range in set notation? We're really going to think about that for discrete values. So we're going to think about the domain, and the range is the set. So here, I'm listing all of the x values. So 1, 2, 3, and 4. And all of the possible y values, well, that's sticks, M&Ns, and duds. So it's really just listing all of the possible values. Go ahead and pause the video and try the next two. And here you go, so you can check your answers. Make sure that you know why I put them in the particular order that I did, and that you have all of the same values. All right, so thinking about domain and range in set notation and interval notation, I'm going to actually do interval notation just because we need to. If the domain is going to go is all of the possible x values, well, if it keeps going in this direction forever, it's actually going to keep going over just a little bit forever. And so one side is going to be negative infinity, and it's going to keep going positive forever and ever and ever. So in the x direction, I'm thinking about the x values, so it's actually going to go all the way to infinity again. And I use soft brackets because it is going to infinity, and we can never get there. Now the range for this guy is all the y values, and it goes down forever and it goes up forever. So I think, hey, it's going from negative infinity to infinity again, and so we've got set builder notation. Number 5, let's take a look. Well, the lowest x value is -3. The highest value is 3. It could be equal to 3 because it's a circle, so I'm going to say it's going to be from -3 to 3, and it includes 3, so I'm going to use hard brackets, and that's the domain. And the range is the y values, and it also goes from, and I'll do it in blue, 3, the range in blue, to +3, -3 to +3, and it could equal 3. So hard brackets again, -3 to +3. Go ahead and pause the video and try these next two. All right, so you've checked your answers. Please send me an email if you have questions. I hope this video was helpful.